let's have a look at some box plots. So box plots are just a representation of the 5-figure summary, and as always, a graphical representation is a great way to compare data. You can see I've done a little bit of that on the right, so just looking at the top 10 players for assists and goals over 2 seasons in the Premier League. And as you can see, Mo Salah at the bottom there, 32 goals in a season, was a clear outlier. Well, actually not technically an outlier, but a long arm on that box plot, a long whisker, it's sometimes called as well. So you can kind of see comparing there that he was well ahead of the bulk of the top 10, whereas in the season 2018-2019, it was a little bit closer, all at the top. In fact, in that year, there were 3 players that scored 22 goals altogether. Anyway, let's get into it. So our middle of our box plots you can see represented is by Q2. Our lower quartile is Q1, upper quartile Q3, and then our maximum and minimum. Sometimes you'll see a little kind of dash at the end of the box plot, or it's just a line. And then outliers, as you can see in this example here, is listed as a cross or sometimes a dot as well. So I'm going to show you how to do this via technology first, and then we're going to have a go by hand. So here we have a whole bunch of data, and our first step is to enter it into our CAS calculator. So I'm using the TI Nspire, the Texas calculator, and I'm going to open one of these lists and spreadsheet pages. First thing to do is just list your data title, so I'm just going to do A for the moment, and I'm just literally going to type these numbers in. So I'm going to pause and do that, and you'll see what the result looks like in just a moment. So you can see I've entered the data. It's not in order. It doesn't have to be when using technology. If we're doing it by hand, we would need to order it. And something that we can do is menu, statistics, stack calculation, and one variable statistics. Just leave that as 1. This will always be A, so that's the column that we're looking at, and we want our results in B. And if I click OK, I think that's all good. So this is the information that we're getting here. So we're actually given our 5-figure summary down here. So our minimum, quartile 1, median, quartile 3, and our maximum. So we can actually find that just in this page. But another way we can actually do that as a box plot is if we click the on button, and then this data and statistics page, I'm going to add our A value at the bottom. So we're getting closer now. Menu, plot type. And as you can imagine, we're doing a box plot, and it actually does all the work for us, and we can see we have an outlier at 12. So I'm going to snip this in so we can have a look at it in OneNote. So there you go. So we can do all of that via technology. We can clearly see that we have an outlier at 12, so that's what we wanted to mark, an outlier, which we've done successfully, and we can state that we have one at 12. We could find that mathematically if we wanted to check that. So that is our quartile 3, which is 6.5 plus 1.5 times our interquartile range, which is, whoops, that's not right, which is 3, and that gives us 11. So clearly 12 being greater than 11 is an outlier. So technology is really beneficial, and basically whenever you're doing these questions in year 11 and 12, you will be using a calculator of some kind. So I highly recommend that you get familiar with how to use that effectively, and I'll put up a Word document explaining how to do some of these tips with the Texas CAS calculator. So let's have one more go at this by hand. We've got these sugar amounts in all these various drinks per 100 ml. This is real data as well that I grabbed online, so feel free to check out that link at the top right. So of course, finding our quartile 2, we're talking about the average between these two numbers, so 10.35. Quartile 1 will just be 5.8. Quartile 3 will be 10.85. If you're not sure about how to find that stuff, just have a look at the previous video as well. Minimum is 4.3, maximum is 13. Our interquartile range, 10.85 minus 5.8, which is 5.05. So we've got all that information. We want to draw this as a box plot. So I tend to mark quartile 2 first, so 10.35, so around about there. Then quartile 1 is 5.8, so let's go about there. I might be a bit off here, but that's okay. 10.85 is going to be about here, so it's a pretty small little thing. And our maximum is 13. minimum is, what was that minimum? 4.3. Oh no, right about there. Well, that's not very good. Okay, so let's box up our middle here. Alright, so we have our box plot there. You can kind of see that there's portions of this that represent 25% of the data. So 25% is here, 25% is here, 25% here, and 25% there. So you can see there's a kind of large spread of data in this section here, but there's quite a kind of grouping up the top end here as well, which is around those 10s that you can see from the data as well. So calculating for outliers, so finding my lower fence, I'm going to use my quartile 1, so 5.8 times 1.5 times our interquartile range, which is 5.05. As you can see, you'd probably have a calculator for this type of thing. So we obviously can't have negative sugar in a drink, so there's no outliers on the lower fence. And our upper quartile is 10.85 and times our IQR 5.05, and that gives us 18.4. So no outliers up the top either. So that's it. We've done our box plot. That's everything we want to do, but of course we could use technology for that as well. Tough little question from the textbook here. It would be a bit of a pain to do by hand, so I'm going to use technology. This is looking at spelling errors from different exams, and I've typed that data in the CAS here. Our next step is to use the On button and open a data and statistics page. And if I click A down the bottom here, menu, plot type, box plot. And if I do menu, well, I can right click. Oh, this is confusing. Hold on. Menu. I'm going to remember how to do it. That's right. Add X variable, and I'm going to add B. So we now have the two being compared. On my computer version, I can right click here and add an X variable, but there you go. That is obviously a really useful thing to be able to do. So this person marking the same papers found a lot more spelling errors, whereas this person did not. So the questions then say, do you believe there is a major difference in the way the essays were marked? I would say yes, as far as spelling errors is concerned. In fact, the minimum here is kind of above nearly 50% of the data. So you could say that the person B is just a harsher marker, or person A is too lenient. We don't really know the specifics of that, but we can describe that difference. And in fact, our median here is 12, so it's actually twice what our marking of A is. So that's why putting them together and comparing is really useful. If we just looked at those numbers, it's certainly less obvious. Maybe that this one's a harsher marker, but I think by having a graphical representation is much nicer than trying to do it based on the numbers.